Hello everyone, thanks for tuning in to my YouTube channel. This video is going to be really quick, talking about the domain of a function, and I have a few examples on different types of functions that we need to look at domain. This is specifically made for my pre-calc class, and the very first part of the chapter 1, probably I think it's like section 1.3 and 1.4, where they ask you about domains. First of all, we talk about the domain restrictions right here. Domain restrictions, if it's a rational function, and again, remember a rational function is like a fraction, we want to make sure that we can't have zeros in the denominator. If we have a square root as the function, we can't have a negative number under an even radical. So if it's a square root or a fourth root, anything where the index number is even, we can't have a negative number underneath that. Okay, so we're going to look at our first one right here where we have 1 over x squared minus 16. Now most things, as always, we factor, and we know this is x minus 4 and x plus 4 for a difference of squares. So we know that the domain here is going to be all real numbers except x can't equal plus and minus 4. So all real numbers except for negative 4. So that's one way of writing it out in words. We can write it in a little set notation where we say that x is an element of the real numbers such that x cannot equal negative 4 and 4. So that's like a little fancy script notation there for mathematical notation. We can write it in with intervals, and intervals is something you see a lot of. We make a number line, and we know we got from negative 4 to 4 here, and we're looking at all the numbers except negative 4 and 4. So this whole set of numbers here is from negative infinity to negative 4. And then we jump the negative 4 and we go between there, so negative 4 and 4, and then union with the second last part, or third part here, right? We're going to go from 4 to infinity. We can write it that way. Okay, so that's another way different ways we can talk about the domain. So let's look at a couple more examples. That's all we're going to do today. Here's my square root. So when we have a square root, we want to make sure that whatever's underneath the radical right here, we want this to be positive. So we take the inside, x plus 6, and we set it greater than or equal to 0. So simple on solving this one, x is greater than or equal to negative 6. So that's a way of saying the domain is all the numbers that are bigger than negative 6 are going to work for the domain. So if we were to use that fancy script notation, again, x is an element of the real numbers such that x is greater than or equal to negative 6. So we can do it that way. We can just leave it with the inequality notation, or we can just write it out in words. All numbers that are bigger than or equal to negative 6. Alright, so what happens when we combine a radical in the denominator? So if we combine the two, the inside we still want to be greater than 0. Now notice that we have not put an equal to sign underneath, because we don't want that to happen, because we don't want it to be 0 in the denominator, because you know you can't have 0 in the denominator. So when you have a radical that's in the denominator, you just have to set it greater than 0. So we're going to have x minus 10 greater than 0, not greater than or equal to like we did before. So the domain here are going to be all the numbers that are bigger than 10. Okay, and then last but not least, we're going to have another one over here where we have the square root of x squared minus 9x plus 20. Now when you get a little bit more complex underneath here, we're still going to take the inside, okay? We're still going to take the inside and set it greater than or equal to 0. Now what we want to do here is make sure, erase that there, we still want to make sure we're setting it greater than or equal to 0. Now what we want to do here though is probably what you're thinking here is we're going to factor this. We're going to go with x minus 5 and x minus 4 Okay, and that's going to be greater than or equal to 0. Now the best way to do this is, now we have a couple different zeros underneath there. The best way to do this is draw a number line. And we're going to do this 4 and 5, because that's the zeros we get here. Okay, we actually call these critical numbers or critical values in calc. What we do is we're going to pick test values. So we're going to pick a test value on this interval, and this interval, and see if it works. So a number that's going to be left of 4 or less than 4, I'm going to try 0. So if I put 0 in here, I get 0 minus 5, I get negative 5, times 0 minus 4, that's negative 4. So negative 5 times negative 4, that's 20. Is 20 greater than or equal to 0? It sure does. So this interval works. Okay, so next thing I want to do is I'm going to pick a number between 4 and 5. So how about 4.5? So if I pick 4.5, 4.5 minus 5, that's going to be negative. So I'll have a negative number there. What about 4.5 minus 4? That's going to be positive, like a half, right? So I got to have a negative times a positive. That's a negative. Is a negative number greater than or equal to 0? No, that does not work. So this interval is no good. And then, last but not least, I pick a number over here bigger than 5. So I'll pick something easy like 10. What happens when I plug 10 in here? Well, when I plug 10 in here, I'm going to get a positive number, because 10 minus 5, that's 5, that's positive. What happens when I plug 10 in here? Well, that's going to be 6. So I get another positive number. Positive times a positive, that's equal to a positive number, which is greater than or equal to 0. So that actually works. So this interval works. So when it's all said and done, I know this interval checks out and this interval checks out for my domain. So writing it in interval notation is probably your best bet. And so what we say is, knowing that the first interval here is going to be from negative infinity to 4, and then from 5 to infinity. So that's some quick examples of doing some domain problems here that show up at the beginning of Chapter 1 in Pre-Calc. Thanks for tuning in, guys, and if you haven't subscribed to my page yet, please do so.